Hi, my name is Maurice O'Brien. I'm a Strategic Marketing Manager in Analog Devices Industrial Automation Business Unit. Today's talk is titled Empowering the Intelligent Edge to Eliminate Unplanned Downtime. Briefly, in terms of the agenda, we will discuss the goals of smart manufacturing, look at the cost of downtime, talk a little bit about the growth of condition monitoring, and then talk a little bit more about what do we mean by the intelligent edge. And finally, we will discuss some reference designs and platforms that are used to accelerate new product developments. The goals of smart manufacturing are really centered around driving higher levels of sustainability, digitization through digital transformation strategies with a view to deliver more flexible, scalable, and agile automation to support changing consumer demands and support batch size 1 production. One of the major challenges with manufacturing is downtime. So let's take a moment to look at what is the cost of downtime. A recent US Department of Commerce report highlighted that almost a quarter of total manufacturing cost is associated with unplanned downtime. So if we can eliminate that unplanned downtime, we can drive significant cost savings and drive increased levels of productivity. So condition-based monitoring is deployed on all types of automation equipment, pumps, conveyors, with a view to reducing unplanned downtime, also increasing asset lifetime. By using condition monitoring, we extend the usable life of an asset, thereby we reduce the consumption of raw materials and energy used to build replacement assets. So we're actually delivering more sustainable manufacturing. Condition monitoring improves safety by ensuring equipment operates within the manufacturer's specification, creating a more safe environment for employees working with these assets. And then finally, there's improved quality control, again by making sure we're operating assets within their specified range, we are ensuring quality control of the production. So let's talk a little bit about the growth of condition monitoring. So first of all, condition monitoring isn't new. It's been around for many years. But traditionally, condition monitoring was deployed on the 5% of assets, the most critical assets. For example, power generation, air, fluids, whereby if any of these assets failed, the entire production would stop. And what we're seeing now is people wanting to deploy condition monitoring beyond the most critical assets into the other 95% of assets. And that's really what's driving the growth of condition monitoring. So as you see with the icons along the bottom, we're moving from pumps and compressors into drives, CNC, conveyor belts, robotics and instrumentation across a very wide range of applications from smart manufacturing, smart logistics, all the way through these applications. So what do we mean by condition monitoring? Ultimately, condition monitoring is focused on taking real-world phenomena, be it temperature, humidity, pressure, vibration, voltage current, and acoustic, and taking these real-world signals, digitizing them, bringing them into the digital domain, and using edge processing to extract actionable insights that we then use to monitor the health of an asset. Analog Devices is focused on empowering the intelligent edge through the world's most innovative analog, digital, and software solutions. Our goal is to enable more sustainable manufacturing with increased uptime and more flexible, scalable manufacturing. So what do I mean by empowering the intelligent edge? What technologies is Analog Devices bringing? From a sensing modality perspective, Analog Devices have been pioneers of MEMS vibration and shock sensors for the automotive industry. We're now bringing them to condition monitoring applications as a means of monitoring the health of an asset, augmented by other sensing modalities like temperature or magnetic field, voltage, and current. And then we take all of these analog sensing modalities, we use high fidelity data acquisition to bring them into the digital domain. where we use ultra-low power microprocessors to generate asset health data. Then we look to use, for example, a neural accelerator at the edge to extract insights, to do anomaly detection. So we're moving from data to insights. We're using embedded security to secure the communications. We're using authenticators for secure commissioning. And then we need to communicate these asset health insights. From a wired perspective, it could be IO-Link, RS-45, or industrial Ethernet, and specifically new standards for industrial Ethernet like 10BASE-T1L. On the wireless side, we have Smart Mesh, a very robust, ultra-low power mesh network, or BLE. Then we also need to power all of these technologies. So we're focused on high efficiency, low QS and current power management solutions in very small form factor to power all of these technologies. And then finally, we're using cloud insights combined with edge AI to aggregate all of these asset health insights so that they can be monitored and acted upon. Analog Devices is in a unique position to bring all of these technologies together to provide complete end-to-end solutions for condition monitoring. I'm going to focus on 3 key areas for the rest of this presentation. We're going to look a little bit at analog devices, vibration sensing. We're going to look at this Edge AI neural accelerator for anomaly detection at the edge, and we'll take a look at some of the communication solutions available. MEMS vibration and shock sensors are one of the key sensing modalities for condition monitoring. Analog Devices provides a portfolio with wide bandwidth, low noise, cost-effective solutions when compared to piezo sensors, stability over temperature and life, multi-axis solutions with ultra-low power consumption to extend battery life in wireless applications, and very small form factor solutions. Examples include the ADXL 1002, a high-performance, high-bandwidth single-axis MEMS sensor, or the ADXL 356 as an example of a 3-axis MEMS sensor. Edge AI and the opportunity to use a neural accelerator chip to do anomaly detection at the edge. A more powerful means of anomaly detection at the edge can be deployed with a neural accelerator chip. It provides a very low latency decision making at the edge. We're not waiting for commands to come back from a cloud-based analytics solution. It's a data-centric learning approach which reduces the need for domain expertise, which is very important if we're going to scale condition monitoring to a wide range of assets. Transmission of insights and not raw data extends battery life in wireless applications. Analog Devices MAX 78000 neural accelerator chip provides the industry's lowest inference time and energy to provide an ultra-low power edge analytics solution that ultimately reduces development time. From a connectivity perspective, we provide both wired and wireless CBM connectivity options. So on the wireless side, we have Smart Mesh, or wireless HART, very robust, ultra-low power, mesh-based network, BLE processors for commissioning. On the wired side, we have IO-Link, 4 to 20 milliamp, including IEPE, RS-422, RS-45, and Ethernet. And specifically, I'm going to take a moment to look in a little bit more detail on a new industrial Ethernet physical layer called 10BASE-T1L. So Ethernet today in your home, it requires 4 pairs or 8 wires, and it goes to a distance of 100 meters. If we want to bring Ethernet to industrial, and particularly the CBM, we need to use simpler cabling. We need longer distances. So recently at IEEE, a new industrial Ethernet physical layer called 10BASE-T1L was ratified, and we're showcasing how 10BASE-T1L can be used for condition monitoring applications to monitor large amounts of assets, provide a means of aggregating large amounts of condition monitoring data, and make that data more seamlessly accessible. 10BASE-T1L uses low-cost single twisted pair cabling, which is lower cost and easier to install. It supports a distance of up to 1 kilometer and beyond. It provides 10 megabits of bandwidth, Both power and data share the same single twisted pair cable. So you can provide power on the same single twisted pair cable as your Ethernet connectivity. And the advantage of Ethernet is that no gateway is required to your higher level connectivity. You no longer require a gateway as you do with RS-45 IO link. You've got seamless Ethernet connectivity. You've got data transparency right down to that edge sensor, where you can be anywhere in the world, you can have a tablet in front of you, and you can see that asset health data. And Ethernet provides the ability to scale the amount of assets, but also scale bandwidth. You can aggregate large amounts of data very easily with an Ethernet-based solution. Finally, we're going to talk a little bit about analog devices, reference designs, with a view to their distinct advantages. So ADI puts a lot of effort in combining our technologies to make it easier for our customers and partners to develop and deploy their own condition monitoring solutions. So we provide faster time to market with simplified designs. Open source software enables easy integration, mechanically proven designs, robust and reliable performance to provide deep diagnostic insights. So we provide a range of development platforms from very simple circuit nodes where we combine an ADC and an ADC driver, or we provide a MEMS sensor with an IEP interface. And then we step up and we solve also the mechanical challenge. If you're going to use a high performance 10 kilohertz MEMS sensor, part of the challenge here is the mechanical enclosure to pick up those small signal vibrations. So we as Analog Devices provide mechanically proven solutions to ease the development with our MEMS sensors. We provide connectivity solutions. So for example, with Pioneer 1, we showcase how to use our MEMS sensors with RS-45 connectivity. CN0549 is a complete CBM development platform. It showcases our MEMS vibration sensor. It comes with a mechanically proven cube for mounting the sensor on the asset. It has a 24-bit Sigma Delta data acquisition card and is paired with an FPGA card. So it's a complete self-contained vibration development platform. And we provide the data bindings to bring that high fidelity vibration data into data analysis tools like TensorFlow and Python. So a data analyst can take this platform, not worry about any of the hardware, mechanical sensing element. They can just focus on using the data and ultimately developing their own algorithms to deploy for asset health monitoring. Voyager 3 is an example of a wireless platform. So here we have an IP-rated enclosure with a 3-axis vibration sensor. It's smart mesh enabled. It comes with a mechanical mounting cube, and you can mount this on an asset in the field to start generating data with a view to understanding and characterizing, well, what do I need to monitor on this asset with a view to accelerating their own developments. And finally, we have ADI AutoSense SMS. So this is an AI-based, full turnkey hardware software solution for condition-based monitoring. So this is a fully deployable solution. You buy the box, you mount it on the motor, and ADI provides the cloud-based infrastructure over a monthly subscription model to provide all the asset health data in a complete end-to-end solution. So that concludes my presentation. To learn more about Analog Devices technologies for condition-based monitoring, please visit analog.com/CBM, or please visit booth 5108, where we're demonstrating a lot of these technologies. Specifically, the 10-base T1L is one of our main demos on the booth. Thank you all.